Scientists want to use lasers to guide aliens to Earth. So what could go wrong? This is Live Science. Rafi Letzer reports. Now, we could build a laser that could send signals to extraterrestrial intelligence. Now, a new paper published yesterday, November 5th, in Astrophysical Journal found that humanity could feasibly build an infrared laser hot and bright enough that if we shined it directly at nearby exoplanets, alien astronomers should be able to detect it using skywatching technology not too much more advanced than what we have today. Presumably, they're out there, of course. It would have to be pretty huge, but not unthinkably so. One possible design the researchers proposed would require a 1 to 2 megawatt laser and at least a 100-foot, that's 30-meter diameter primary mirror. So that's not too many things that are difficult to get. It's not clear if aliens would immediately recognize the laser as a signal from intelligent life forms. James Clark, who is a graduate student at MIT and the lead author of the paper, said in his statement, but he added, it would certainly attract attention. The main challenge for building an alien laser beacon, the authors wrote, is that Earth is not alone in space. Instead, it's a relatively minor one of 8 planets orbiting a star far brighter than any laser humanly could reasonably hope to produce. From the perspective of an alien astronomer hundreds of light years away, the entirety of human civilization and any infrared source it might produce would be drowned out by the gigantic white-hot source of light in our local space. The goal of the laser, then, would not be to create a blinking beacon in the darkness for aliens to sit up and notice. Instead, the author says, it would be to make our sun look weird enough from an alien perspective to take a second look at us. Instead of aliens scanning the sky may have noticed that our sun has planets around it, or that at least one of those planets might possibly be habitable. But that does not seem to be all that rare. Maybe if they're on TRAPPIST-1, which shows the largest number of exoplanets that could conceivably have liquid water at their surface, they'll have taken special notice of our system for the same reason we've taken notice of theirs. The possibility of habitable worlds a mere few dozen light years away. But if we pointed a laser at the scale Clark images directly at those aliens while they were looking at our sun would seem to exhibit some very unusual behavior. Under normal circumstances, stars vary a bit in terms of how much light they produce, and there are patterns to that variation. A focused infrared laser, though, could make our sun's light output vary far more in the infrared spectrum than is normal. Instead of creating a blinking beacon in the dark, the laser would make our sun appear to be an existing light that had gone wonky. If aliens nearby detected the signal and understood its significance, it might be possible to set up a communication channel using lasers with data transfer rates of up to 2 megabits per second. That's similar to a slow modern internet connection. Of course, there would be time delays of decades between the sending and receiving of messages thanks to the speed of light. Farther away from Earth, the researchers found the laser could still be used to broadcast a more general, hey, we're here signal, detectable from up to 20,000 light years away. Of course, space is much bigger than that. A 20,000 light year signal will only reach the other stars in our general region of the Milky Way. There could be some dangers to shining a super bright infrared laser into the sky. Infrared is not visible to the human eye, but a targeted intense beam could still blind someone. As long as reasonable safety precautions to prevent anyone from looking into it were taken, though, it should be fine, they wrote. As to whether any of this is a good idea, that's a question for readers to answer for themselves. Perhaps after reading Cixin Liu's novel, The Three-Body Problem. This was originally published on Live Science.